Alright, 2016 AIME 1, question 11. Let p of x be a non-zero polynomial such that x minus 1 times p of x plus 1 is equal to x plus 2 times p of x for every real x, and that p of 2 squared is equal to p of 3. Then p of 7 halves is equal to m over n, where m and n are relatively prime integers. Find m plus n. So, the first thing I notice is p is a polynomial, and I can find some zeros of that using this equation. So for instance, when I put in x equals 1 into this, I'll get 1 minus 1 times p of 2 equals 1 plus 2 times p of 1. This is, of course, 0, so p of 1 equals 0. Similarly, when I put in negative 2 here, I will get negative 2 minus 1 times p of negative 1 equals negative 2 plus 2 times p of negative 2. Negative 2 plus 2 is 0, so that means that p of negative 1 must be 0. Okay, now I can actually get one more 0. Let me make sure I go the right way. So these get me from like p of x to p of x plus 1. And if I start here, yes, that's going to work out. So I know that p of negative 1 is 0. And so if I make x equal to negative 1, and I get negative 1 minus 1 times p of 0, equals negative 1 plus 2 times p of negative 1, I see that this right here is 0. Those are not 0. That means p of 0 must also equal 0. And that leads me to the fact that this polynomial p of x must have factors of x minus 1, x plus 1, and x. So I like writing it sort of in some type of increasing or decreasing order, so I do x minus 1, x, and x plus 1. That's going to ensure that I have 0. So if 1 is a 0 of the polynomial, x minus 1 is a factor. If negative 1 is 0, x plus 1 is a factor. But it's a polynomial, so there could be some more terms left over, and we'll represent that as q of x. Okay, now if I can figure out q of x is, then I'll have the polynomial, and I can put in 7 halves and get myself an answer. So let's move on to that. The first thing, I don't know if q of x is a constant or q of x is a varying polynomial. So I'm going to go ahead and just use this formula again, replacing this p with this term here. So I have an x minus 1, and then p of x plus 1 will be x plus 1 minus 1. Let me actually, so I have x plus 1 minus 1, which is just x, times x plus 1, times x plus 2, times q of x. And this says that's equal to x plus 2 times p of x. So I'll bring in the x plus 2. And then p of x is this without anything changed, so times x minus 1, x plus 1, times q of x. And dividing out terms, I can divide out an x minus 1, divide out an x, divide out an x plus 1, divide out an x plus 2. Ooh, I did make a mistake. This side was gotten from p of x plus 1, so this should have been q of x plus 1. I hope people weren't upset by that. I missed that the first time through. So in here, I'll get q of x plus 1 equals q of x for any x. And so there could be cases like I could give a cyclic function like sine, that sine of what's it going to be, 2 pi x, where this would be true. But it's polynomial, and the only way to get this to be true for all x's is if this is equal to some constant. So now I know that my polynomial is just going to be some constant times all this mess. So some constant times x minus 1 times x plus 1. Okay, now, next thing, if I can figure out some value, a p of some number, I can figure out what c is. So that's where I'm going to go. They give me this piece of information here saying p of 2 squared equals p of 3. So I'm going to write this now. I'm going to let me put a little. I'm going to write this. So I have a p of 2 and a p of 3 in it. So I'm going to make x equal 2. So this will be p of 2 and this will be p of 3. So x is 2. So I have 2 minus 1. P of 3 equals 2 plus 2. P of 2. We're told that p of 3 is equal to p of 2 squared, so we have 1 p of 2 squared equals 4 p of 2. Divide both sides by p of 2, I'll get p of 2 equals 4. Or equals 0, but in here, since 2 is since this is a non-zero polynomial, if this were 0, the only way to make that work is if c is 0, and it would be 0 all the time. So I'll only consider p of 2 equaling 4, and I can use this information to say, okay, we know p of 2 is 4, and we also know that p of 2 is going to be c times 2 minus 1 times 2 times 2 plus 1. So 4 equals 6c, and therefore c is now 2/3. And what this gives me, I'm actually going to write it down here because I'm going to probably use, well, I'll write it up here. So this gives me a defined formula for p of x. It's going to be 2/3 times x minus 1 times x plus 1. Oh, sorry, I didn't do it in that order. Still not wrong, but times x plus 1. And now, changing colors one last time, I can use this formula to evaluate p of 7/2. So, p of 7 over 2 will equal 2/3 times, and then 7 over 2 minus 1 is 5 over 2. 7 over 2 straight up as x is just 7 over 2. And 7 over 2 plus 1 is 9 over 2. And as I've always shown, let's get rid of some junk before I do this so I can cancel out a pair of 2's. And I can reduce this to a 3 over 1. And multiplying through, this will give me 5 times 7 times 3. So I'll do 7 times 3 first and get 21. Times 5 is 105. That was probably easier than going the other way. All divided by 2 times 2. And that implies that m plus n will equal 105 plus 4, which is 109. Comment with questions, and I'll move on to the next problem.